Okay, this question always a little bit tricky. Let's actually draw a diagram, think about what's going on here. So the idea is we've got a shadow stick here and a shadow stick here. We don't actually have to have one on a tropic, so it doesn't have to be directly overhead, although originally I think that's how it was done. We can look at these two right here. And the general idea is going to be, if we have some little angle there, purple angle, we'll call it theta, and the distance between the sticks is L, we're going to say that theta divided by L is equal to 360 divided by the circumference of the Earth. And so that's a really good starting point, because that tells us then, well, what do we need? We need to measure theta, we need to measure L, and then we can get the circumference. So how do we measure L? We have to get people to walk, like pace it out. I don't know, walk, pace it, some way of measuring the distance between the two cities. How does the shadow stick bit actually work? Let's draw a diagram of that. So here's your shadow stick right here. There's the ground, and maybe the sun is in the sky up here like this. So what's going to happen is the light from the sun's going to come down, and it's going to hit the ground right there. And so you're going to get a big, long shadow along the floor here. Now, what we actually need is the altitude of the sun. So the altitude of the sun is this angle right here, this green angle. How do we get that? Well, you could use trigonometry, which you should know now. So if you measure the length of the stick, I'll call it, I don't know, h, the height of the stick, and s, the length of the shadow, then you can work out the altitude of the sun. Maybe you could try and measure it directly, but really you measure the length of the stick, measure the length of the shadow, and calculate it. Now at your two different locations, very quickly, let's sketch this out slightly differently. Maybe the sun's a little lower in the sky, your shadow stick is still kind of the same height. And so what you end up getting is a way longer shadow. And so the angle, when you work it out, is smaller. And what we find is that the difference between these angles, this is equal to our theta. Okay, so often we do this with one vertical shadow. So we have the shadow stick right there and the sun above it in the sky. And then we have the light rays coming down. So that's 0. And then when we compare it to another one, it's like if this is 30 and this one is 0, or sorry, it would be 90, wouldn't it? Would it be 90? I've got confused. Either way, it doesn't matter. The important thing is the difference between the angles gives you this little angle right here, theta.